Okay, there's a few more examples for integration using substitution. So this is similar to the first one we did, but instead of using u equals 2x plus 5, we're doing a u squared equals 2x plus 5. So let I equal the integral of x times the square root of 2x plus 5 with respect to x. Okay. So now, this time then, if u squared is going to be equal to 2x plus 5, then that gives us u is going to be equal to the square root of 2x add 5. Okay. So it stops us having to use to substitute in u to the power of half for that square root. Okay. So that's the square root of 2x add 5 part sorted. So now we need to get a substitution for dx. So to make the differentiation easier, we're going to use implicit differentiation to get that. So we're going to differentiate everything, and remember, we're going to any u we differentiate, we're going to multiply by du by dx. So that'll be 2u multiplied by du by dx equals 2. Okay. So if we cross multiply here, we'll get u du by dx equals dx, because when we take the 2 across, I'll cancel with the 2 on the left hand side. Alright, so that's the square root of 2x plus 5 and the dx part sorted. So now we just need to sort out the x. So if we go back to u squared equals 2x plus 5 and rearrange that to get u squared subtract 5 over 2, and that's equal to x. So again, I keep normal working out there on the left hand side. So we now have everything we need to substitute into that original integral to turn it into terms of u. So that's going to be I is going to be equal to the integral of u squared take away 5 divided by 2 multiplied by u multiplied by u du. So we just tidy that up and then we're good to go. So I'm going to take the half out again, and then we're going to multiply the two u's together just to simplify a little bit. So we'll have a half times the integral of u squared multiplied by u squared subtract 5 with respect to u. And if we just expanded that bracket, we've got something really simple then to integrate. So we have I is going to become a half the integral of u to the power of 4 subtract 5u squared with respect to u. Okay, so again we've turned it from something complicated to integrate to something simple using C1 integration. So that'll be a half multiplied by u to the power of 5 divided by 5 subtract 5u to the power of 3 divided by 3. Now if you multiply with that bracket, we're going to get I is equal to u to the power of 5 over 10 subtract 5u to the power of 3 over 6 plus c, don't forget. And then all we need to do now to finish off is substitute our expression for u back into our final answer. Okay, so we're going to substitute in the square root of 2x plus 5. So that's going to give us the square root of 2x plus 5 to the power of 5. Sorry, but this is going to be a bit messy as I'm running out of room here. Over 10 subtract 5 brackets 2x plus 5 over 3 divided by 6. We'll just rub out that 3 and make it look more like a 3. There we go, well, a little bit more like a 3. Shrink that down, and then obviously don't forget the plus c as well, and then that's that, done. So let's do one more example. Right, just make this a bit more Star Wars. So we're going to evaluate this integral here from 0 to 2 of x multiplied by x plus 1 to the power of 3 with respect to x. Okay, we're going to choose our own substitution. Alright, but this time now we're going to have to substitute the x, the x plus 1 to the power 3, the dx, and the limits on the integral as well, as they are integrating between between x's. So let I equal the integral between 0 to 2 of x brackets x plus 1 to the power 3 with respect to x. Okay, and I think a sensible substitution to use would be u equals x plus 1. So let's do that. So let u equal x plus 1. Alright, so we need to get an expression for x, expression for x plus 1 to the power 3, and dx and the limits as well. Okay, so the x plus 1 to the power 3 and the dx bit are going to be easy now. The one you're likely to forget to do though will be the limits. So my advice would be is to sort out the limits first. Alright, so if we rearrange that, we've got x is equal to u plus u minus 1. Okay, du by dx is going to be 1. Alright, so du is equal to dx. Just using the u expression at the top for that. Alright, and now let's use this to sort out the bracket. So obviously that's just going to be u to the power 3. We've sorted out the x, we've sorted out the dx bit. So let's just sort out the limits, okay? Like I said, is the limits maybe the thing you might forget to do in this kind of question. So it might be an idea actually to do the limits first. Alright? But let's just make a little table. So we've got x and u. And we are literally just going to substitute 0 and 2 into this expression here to get our new limits. So when x is 0, u is going to be 1. When x is 2, we're going to have u is equal to 2 plus 1. So u will be 3. So that's everything we need to use there in the left hand side. So let's just start our substitution and see how we get on. Okay, so our integral is going to become the integral between, instead of 0 to 2, is going to be 1 to 3. X we know is u subtract 1. I'll stick that in there. U is equal to x plus 1, so x plus 1 to the power 3 is going to become u to the power 3. And dx this time, that substitution is easy, we're just going to replace dx with du. Okay, done. Now because we're doing definite integration this time, and the 1 and the 3 are values for u, we don't need to reverse the substitution at the end. Okay, we'll see now. So it's going to be the integral from 1 to 3. U to the power 4, subtract u to the power 3 with respect to u. So when we integrate that, we will get I is equal to u to the power 5 over 5, subtract u to the power 4 over 4. Because it's definite integration, we don't need the plus c, we just need our square boxes, 3 and a 1. Okay, so like I said, we don't need plus c this time, that's for indefinite integration, which all the other examples have been about, so don't put that in there. Okay, again, these 3 and the 1 are u values, so there's no need to change these back into x's and make it more complicated. We just use the 3 and the 1 to work out our value. So cast your mind back to C2, that's going to be 3 to the power 5 over 5, subtract 1 to the power 4, oh sorry, 3 to the power 4 over 4. Stupid of me. And now we substitute the ones in. So 1 to the power 5 over 5, subtract 1 to the power 4 over 4. Okay, you can work that out and simplify it if you want, or you can be lazy like me and just whack that all into your calculator to get your answer. Okay, so just in case you don't know what a calculator is, there's a calculator. Okay, so just use the fraction buttons, the power buttons, effectively make your display in your calculator look like that at the line, and you'll get, so basically type that into your calculator Let your calculator do all the work for you. And your answer should come out as 142 over 5, which is 28.4. Okay, so that's it for substitution. That should be enough to take you through the exercise. Good luck. Okay.